Welcome guys to another video with Hudson Lighting. I'm Chris Hudson and today I'm building, or hopefully going to build, a swimming pool light, the front and back. Now I'm going to start with the aluminium that we have in stock, which is, this is 70mm diameter by I believe it's 30mm deep. Now the light itself needs to be 59mm in diameter because we're replacing the existing lights, or doing a prototype for the existing lights, as you saw in the last video. If you haven't seen the last video, click here. So yes, I'm going to use these blocks of aluminium to do the front and back. The good thing with using a bit of 70mm is that I can basically create this with a lip, so that we can actually have something that will cover the existing hole. So what I'm going to do is I'm going to set up the machine with a chuck. So we're going to use this chuck, this 3-jaw self-centering chuck. I'm going to get that into the machine. Normally what we would do, so normally we use these parts, we have the jaws turned around like this, so that they're facing around that way around. You can see this part fits in there quite neatly. In fact, if I just quickly just do this up, and it goes on the outside step, which is quite useful because it means that the chuck interferes the least amount with the part, so we can do what we need to do. But because we're using 70mm aluminium, now for the back I would obviously normally buy 60mm aluminium and just take that 1mm off. We're using stock aluminium because this is a test, so it's just our first prototype. I'll just use what I've got in stock. So I'm going to set the machine up, write the program, and then I'll bring you guys back in for the machining bit of it. There's going to be 2 ops for the back and 2 ops for the front. Guys, so we've got our swimming pool lights ready for anodise now, so that go through wash and anodise. So this is our titanium jig for anodising. That's the base plate, and that's the front plate as it is. Should be big enough to cover the hole, and I've just got a couple of other parts on there. So what we'll do is we'll go get those in the tanks, and I'll talk you through the processes in there. So, we're going to start with assembly on the back. What we're going to do, I'm going to give this a clean, and then basically the cable is going to come through the back here, through this hole, and then I'm going to bring it short at the top, and we're going to fill that with resin. Right guys, so I'm doing the assembly in my kitchen. It's about 10 o'clock, yeah, 10 to 10 in the evening. I just want to just get this done really. So I've got together the parts, and I'll show you what they are. My head's going to be out of shot, but you'll see the parts nice and clearly, so that's the main thing. So we've got the 12 watt lens, So I say it's a 12-watt lens. Basically, we use this in our high-powered spotlights. So I'm trying to make parts as universal as possible. So that lens will go in here. Now I've got the base of the fitting. So at the moment I've just resined in the cable into the bottom here, so that we're not going to get any water coming up this way. That blue stuff there is not blue tack. It is actually the heat putty that we use for the LED interface. We've already got our 2 screw holes for the holder, and they are drilled and tapped for M3, so we've got our 2 M3 screws here ready to go for that. So well, let's get on and do the actual connections, etc. So guys, I have finished putting this fitting together. So I've put the O-ring on. You can see the O-ring there, and I'm not completely happy with the way that O-ring is. I would rather the top cover the O-ring, so that will be obviously something that I want to adjust to the fitting. I'm also not completely happy about how far the lens sticks out the top. I don't know if you can see that on the edge or not. So they're 2 things that I can certainly improve on. It doesn't stop us from actually testing the fitting. It is incredibly bright, so I think light wise it's going to be, yeah, we're going to be good there in terms of the output for the pull. So what I'm going to do now is I'm going to put this in the water, and we'll leave it to test underwater until probably tomorrow morning. So that's about 1 meter at the moment. So sorry, excuse the mess as usual. So that's about 1 meter at the minute. I would put it at 2, but the cable is only as long as that. In fact, actually, if I just disconnect one of these leads, let's do that. Right, so now that is at 2 meters, so it's 2 meters deep, sitting at the bottom there. There's no bubbling I can see that's coming out of the lens or the O-ring edge, which is good to see. Nothing to see on the back of the cable. So we'll leave it there until tomorrow morning. Tomorrow morning I'll pull it out and I'll disconnect it, and see whether or not there's any water ingress. If there's no water ingress, we'll leave it for another probably 48 hours. If after 48 hours it's dry, then we will basically take it to the swimming pool and put it in temporarily there, and then hopefully we can get some feedback on what the light output's like versus what's there at the moment, whether or not they're happy with the colour, because they were talking about having 4000K. I put 3000K in there at the moment. The existing lights are halogen, so they're about 2.5 to 2.9 really with halogen. So I opted for 3000K because there's a load of Collingwood lights around the top that I believe are 3000K. So I was kind of trying to keep with that colour. The manager at the gym was saying that he would prefer something cooler, going towards more 4000K. But see, my problem with that is, whatever colour you have in a space, it needs to be consistent, doesn't it? I hope that we all agree on that. Yeah, so let's see how it goes. But so we'll see you guys on the next video. Hopefully we'll be fitting it in the swimming pool. Otherwise, next video will be me going, it failed, and building another one. Anyway, see you soon.